In this session, I will continue from the previous topic of generating power using municipal solid waste as a resource. So the process of pyrolysis or gasification that is used for producing fuel gas, producer gas, or basically a syngas. This syngas is a fuel which can be efficiently used in different equipments like a engine, okay, like in a turbine or in a fuel cell. So in this topic, I will continue with the use of syngas as a fuel in a fuel cell. So what is a fuel cell? So a fuel cell is an electrochemical energy conversion device that uses the chemical energy of hydrogen or other hydrogen-rich fuel to cleanly and efficiently produce electricity. Okay, so as long as hydrogen-rich fuel gas is supplied to the fuel cell, it produces electricity. Okay, so it is something which we can call a reverse of a cell or a battery. From chemical energy, it is producing electrical energy. Because we continuously need to provide a fuel, and the fuel should be hydrogen-rich gas. So depending on the type of fuel cell, the purity of the supplied fuel is desired. So that means that out of the different type of fuel cell, like alkaline fuel cell, polymer electrolyte membrane fuel cell, solid oxide fuel cell. Okay, depending on the type of this fuel cell, the purity that is needed. So like in a low temperature fuel cell, okay, like an alkaline fuel cell or polymer electrolyte membrane fuel cell, we desire or we require a high purity of fuel, that is hydrogen, means pure hydrogen will be desired in case of a low temperature fuel cell. Now coming to a high temperature fuel cell like the solid oxide fuel cell, SOFC, okay, solid oxide fuel cell that works at a high temperature of about 600 to 1000 degrees Celsius. Okay, in this case it is using high temperature, so the purity level of the input fuel, okay, that is considerably lower as compared with a low temperature fuel cell. Like here we need not use pure hydrogen, any other hydrogen rich fuel can be used. So here the gas produced, the syngas or the producer gas or the fuel gas which was produced by the process of pyrolysis or gasification of municipal solid waste, that is a suitable fuel for a solid oxide fuel cell. And further, with the increase in the temperature, the output of the solid oxide fuel cell is also increased. So this is a indication of the blocks of the element components in a solid oxide fuel cell. So there are anode and cathode and a fuel, hydrogen rich fuel, that is supplied to the anode. From there the hydrogen ions, they are moving through the electrolyte to the cathode, and on the cathode oxygen from the air that is being supplied. The oxygen that combines with the hydrogen ions and it produces water. So what is the output? That is water. That is why it was mentioned that it is producing electricity very cleanly. Okay, now this anode and cathode, they are connected via load in the outer circuit. Okay, when the hydrogen that is dissociated from the anode, that is producing hydrogen ions and electron. So this electron is moving out through the outer load from anode to cathode. So this constitutes the current. So we can connect our load, and through that we will get the electric output. So the effect of tar on the performance of solid oxide fuel cell. Yes, so this tar, it is present if the input gas or the fuel gas that is not pure. So we need to remove the tar. Okay, I will discuss it. So what is the effect? The performance of SOFC, the solid oxide fuel cell, gets inferior and a high amount of carbon accumulates at the anode. So the syngas, which is used as a fuel in a solid oxide fuel cell, that should be purified. So it needs pre-processing Okay, so techniques like hot or cold gas treatment or scrubbing, these type of techniques are used so as to remove these impurities like tar. Okay, then we supply to the anode or the fuel cell. Okay, next the integrating the gasification process with high temperature fuel cell. So as just in the previous video, I shared about the process of producing syngas from gasification. So gasification is also taking place at high temperature. So solid oxide fuel cell that is also working on high temperature. Okay, so the heat required for the gasification that can be obtained from the high temperature solid oxide fuel cell. So the heat coming from the fuel cell that is uh, taken and supplied to the gasifier. So we don't need to produce heat separately for the gasifier. So what this will increase the efficiency of the system, or system consisting of gasifier and the fuel cell. Now both are integrated, and heat from the solid oxide fuel cell that is being supplied to the gasification, and thereby increasing the efficiency of the system. Okay, so I shall stop here.